We're going to go over the Unit 5 Homework 3, the odd problems. Starting with number 1. So here we're given that AB is congruent to DC. AE is congruent to EC. I'm just gonna sketch this alongside without all the numbers in there. So these two are congruent. These two are congruent. That's your AE and your EC. Your DE and your BE are congruent. And we want to solve given certain things. But we need to, before we solve, we need to be able to classify this quadrilateral and figure out what are we working with here. And let me show you back here. If you, on number 3 here for property, if the diagonals bisect each other, this property proves that you're working with a parallelogram. And so we have, if we look at this, we have that. We have our diagonals bisecting each other. So we know it's a parallelogram. Could we do better? I mean, is there anything, it's a parallelogram, is there anything that indicates it's a rectangle or a rhombus? How far down this line can we go? The only other thing that we're given is that AB is congruent to DC, but that's something we would already know. If it were a parallelogram, one of the properties of a parallelogram is that opposite sides are congruent. So that information doesn't give us anything else. So I'm going to classify this as a parallelogram because we have diagonals bisecting each other, and that's enough to prove that it is a parallelogram. I'm going to erase the diagram now that we've kind of established what we're working with here. And now what are we given? The measure of angle 1. I'm going to highlight these. So the measure of angle 1, the measure of angle 4, the measure of angle 8, and the measure of angle 10. Okay, so that's what we're given, and that's all we know. And we're trying to figure out, is there a relationship or a connection between all 4, or maybe just 2 of them? We just want to come up with some kind of equation. So here's what I'm saying. If it's a parallelogram, that means that AD is going to be parallel to BC, and then angle 8 and angle 4 are going to be alternate interior angles, and they're going to be congruent to each other. And so I'm going to use the property that alternate interior angles are congruent. It's not a property, one of the particular properties that we wrote down for parallelograms, but it is something that's always true because the opposite sides are parallel and you have these diagonals which form alternate interior angles. So that's what we're going to use, and we're going to set the measure of angle 4 equal to the measure of angle 8. So measure of angle 4 is 2x to the third minus 2x squared plus x plus 3. Measure of angle 8 is x to the third minus x squared plus 2x plus 2. You want to first set this equal to 0. I'll set the right side equal to 0 by subtracting or adding whatever is going to make it equal to 0. And we end up with x to the third minus x squared minus x plus 1 is equal to 0. We have 4 terms, so we're going to try to factor by grouping. The first 2 terms we factor out an x squared. What remains is an x minus 1 minus, last 2 terms we factor out a 1, and what remains is an x minus 1. Both terms here have a common factor of x minus 1, so I factor out the x minus 1. And what remains is an x squared minus 1. X squared minus 1 is a difference of 2 perfect squares, so it can factor even further to x plus 1 times x minus 1. So we have 3 factors. 2 of them are the same factor. We have 2 x minus 1s. So we only have 2 different factors. We're going to take our 2 different factors and set them equal to 0. We could set all 3 factors equal to 0, but we're just going to get a repeat answer. So x equals negative 1 and x equals positive 1 are the 2 different answers we would get. Number 3, we're given that AB is 5, so the length, I'm just going to sketch something here. So AB is, the top length here is 5, DC, the bottom length, is 6. The measure of angle 7 is congruent to the measure of angle 3, or sorry, angle 7 is congruent to angle 3. So this angle here is congruent to this angle. And that's all we're given. And so from the given, we're trying to figure out what shape are we looking at. Well, I know it's not a parallelogram because the opposite sides are not congruent, right? If it were a parallelogram, it would have that property that opposite sides are congruent. Because I have, one side's 6, the other side's 5, I know these opposite sides are not congruent, so it can't be a parallelogram. But I do have alternate interior angles here congruent, so the bottom is parallel to the top. Because if you have alternate interior angles congruent, then the top and bottom will be parallel. So the left and the right side can't be parallel, because if they were, it would be a parallelogram. So this has got to be a trapezoid. The definition of a trapezoid says exactly one pair of opposite sides is parallel, the other side is not going to be parallel, and that's what we have here. So what are the things that led me, well, once we know it's a trapezoid, what are they giving us? We have the measure of angle 4, which I'll highlight, the measure of angle 8, and you might be tempted to say that they're congruent because they're alternate interior angles, but the left side and right side are not parallel, so we can't say those are congruent. The measure of DAB, so that's that full angle A there. the measure of BCD, that one there, and the measure of CDA, that one right there. So let's go take a look at what we know about trapezoids. And hopefully you have all this memorized, right? But trapezoids, there's really only one property that we have here, and that is that the same side interior angles add up, are supplementary, or they add up to 180. So like in the picture, angle A and D will add up to 180, or angle B and C will add up to 180. And so over here we have angle A and D, and we know that they are going to add up to 180 because they are same side interior, because the top and the bottom are parallel to each other. And so that's what I'm going to use. So I'm going to write that property down. Alright, same side interior angles are supplementary. And what do I mean? Again, what do I mean by same side? If you have two parallel lines, cut by a transversal, you know, angle 1 here and angle 2 here in my picture would be same side interior, and that's what we're dealing with. Those are going to be supplementary. So I get that the measure of angle DAB plus the measure of angle ADC is 180. From the equation, DAB is x to the third plus x squared minus x plus 3. I'm going to add that with ADC, which is CDA, same thing. So 2x to the third plus 3x squared minus 2x plus 181. All that equals 180. Combine like terms. We end up with 3x to the third plus 4x squared minus 3x plus 184 is equal to 180. Subtract 180 from both sides and you get 3x to the third plus 4x squared minus 3x plus 4 is equal to 0. We have 4 terms here, so we're going to try factoring by grouping. And the first pair of terms we can factor out an x squared, and we're left with a 3x plus 4 minus, factor out a 1 from the last pair of terms and get a 3x minus 4. And then since both terms have the same factor, 3x minus 4, we're going to factor out a 3x minus 4. And we're left with x squared minus 1. And then the x squared minus 1 is a difference of two perfect squares, so that factors to x plus 1 times x minus 1. We end up with 3 factors, giving 3 different answers. So the 3x plus 4, minus 4, gives us the answer x equals 4/3. The x plus 1 gives us the answer x equals -1. And the x minus 1 gives us the answer x equals +1. So those are 3 answers. Number 5 here, we're given I'm going to just do a little sketch here, and I'll erase it, side work here. But AB is congruent to AD, so these two sides are congruent. DC is congruent to BC, those are congruent. AD is perpendicular to DC, so 90 degrees here. And CB is perpendicular to AB. So the first thing to do here is to try to classify this and figure out what it is. The way it's drawn that I came up with kind of looks like a kite, you know, because with a kite you have two adjacent sides that are congruent, but there's an additional thing that we need to know. Opposite sides can't be congruent, and we don't know that opposite sides are not congruent. So it could be a kite as an option. It's a kite if opposite sides are not congruent. If opposite sides are congruent, then what would happen is we would have all four sides congruent, and we would have these two angles being 90 degrees. And if that were the case, well, if all four sides are congruent, it's a rhombus, and because it's a rhombus, it's a parallelogram, and because it's a parallelogram, consecutive angles are supplementary, and if one of the angles is 90, then the angle next to it would have to be 90. So you'd end up with all angles being 90, meaning it's a rectangle and a rhombus, so it'd be a square. So we're either looking at a kite or a square. And we're just not sure which one it is, so there's not enough information to determine if it's a kite or a square, but it's got to be one or the other. So if it's a kite, the properties that we know here are, and I'll pull it up. So kite only has one key property, and that's from 6, and that's that the diagonals are perpendicular. What I want to point out to you as well is if we look at a square also has property 6 because a square is a rhombus, and a rhombus also has that property. So both, whether it's a kite or a square, what we can say for sure is we know that the diagonals are perpendicular. And that's what's going to help us in this problem. So because the diagonals are perpendicular, we can say that the measure of AED is 90 degrees. And so I'm going to write that measure of AED is equal to 90. And we know that AED is 15x squared minus 14x plus 82. and I'll set that equal to 90. I'm going to go ahead and erase my sketches here so I have room to solve. And I'm going to write in what property I'm using, that the diagonals are perpendicular. So now that we're solving, we could subtract 90 from both sides of the equation and get 15x squared minus 14x minus 8 is equal to 0. And because we have three terms, we're going to use trinomial factoring, which is type 5 or type 6. Both good examples there. And so I'm going to try to find two terms whose product is going to be 15x times negative 8 and whose sum is negative 14x. 15 times 8, well, 15 times 2 is 30, and so we're going to end up with negative 120 x squared. And so we just start thinking, well, what times what is 120? So we got 120 times 1. We got 2 times 60. 3 times 40. 4 times 30. 5 times, well, 5 goes into 120. 25 times? No. Let's see. 5 goes into 120. Let me write that out here. 24 times. And I'll do one more. 6 times 20. And we're trying to think which two of these can make negative 14. I'm allowed to use positives and negatives. And if I do negative 20x and positive 6x, that's going to work out for me. So I split this up. 15x squared minus 20x plus 6x minus 8 is equal to 0. Factor by grouping. I'm going to factor out a 5x, and what remains is a 3x minus 4, plus factor out a 2, and what remains is a 3x minus 4. Both terms have a 3x minus 4 in it, so I factor out the 3x minus 4. And what remains from the first term is 5x, and what remains from the second term is 2, and now it's fully factored. So then you take your factors, set them equal to 0, and solve. And we get x is 4/3, and x is negative 2/5. Again, I'm going to start with a little sketch, a little scratch work. Angle 1 is congruent to angle 2, so these two are congruent. Angle 5 is congruent to angle 6. AB is congruent to DC. solve for x. Alright, so first I'm going to do a little investigating, a little bit of thinking. What kind of shape is this? What can we figure out, right? Well, the first thing I want to point out is that the two triangles are congruent because they have a shared side here, and we can say by angle side angle. Okay, again, this is a little scratch work here. Now, and maybe it's helpful if I put the lettering in here. We got A, B, C, D, and so what we're saying is that triangle ABC is congruent to triangle ADC. Okay, and now look at the correspondence here. We have AB, my first two letters, is corresponding to AD. So we know that AB is congruent here, right? And we have DC congruent to BC. So from this we find out that all four sides are congruent, making this a rhombus. And then we have a diagonal bisecting an opposite angles, which is no surprise to us because that is a property of a rhombus. Okay, so so we had to do a little digging here, but now we know what we're working with. This is a rhombus. I'm going to erase my scratch work. And now we're going to look at what we're given. We have angle ADC, so this big angle here, and we have the measure of angle 6 right in here. Now, is there a relationship between those? Again, I'm going to do a little bit of scratch work to help you see something. So if it's a rhombus, first of all, the diagonals are perpendicular. So we can, in our picture, we could say that angle 10 is 90 degrees. So I'm going to write that in here. Diagonals are perpendicular. Angle 6 we have, and we could say this, that the measure of angle, well, so measure of angle 10 is 90. I'm going to write that here. The measure of angle 7 plus the measure of angle 6 plus the measure of angle 10, those are the three angles inside my triangle. It's going to add up to 180. And so we're going to use the fact that the sum of interior angles of a triangle is 180. And then I also want to point out that the measure of angle 8 is going to equal the measure of angle 7, because in a rhombus the diagonals bisect opposite angles. And why is that important? Well, the angle that we're looking at, ADC, so measure of angle ADC, notice that that's made up of the measure of angle 8 plus the measure of angle 7, right? Just by the makeup of that angle. And if measure of angle 8 and measure of angle 7 are equal to each other, that means the measure of ADC is cut in half, right, by the diagonal. And so we can say is that a half of the measure of angle ADC is equal to the measure of angle 7. I'm getting, trust me, I'm almost there. I'm getting somewhere. I know it's a long road here, but we're almost there. Okay, so let's put all this together. So using this big equation here, okay, instead of writing the measure of angle 7, I'm going to write 1/2 of the measure of angle ADC plus the measure of angle 6 plus, instead of saying the measure of angle 10, I know it's 90, so I'm going to say plus 90 is equal to 180. And from that, we're almost there. Half of the measure of angle ADC plus the measure of angle 6 is going to equal 90. I just subtract 90 from both sides. Okay, so that's what I needed, and now I'm going to clear the spot a little bit to get to some solving. And let's see here. Move that over here. Shrink it down a little bit. Okay, now let's put in the equation. So 1/2 of, let's see, ADC would be 12x squared plus 10. So we got to cut that in half. And then add that to the measure of angle 6, which is 10x squared plus 60. And that's going to add up to 90. So half of 12 is 6. Half of 10 is 5. And well, I might as well subtract 90 from both sides here, because we've got to make the equation equal to 0 anyways. So it's going to be minus 30 equals 0. And it's minus 30 because I'm subtracting 90 from the 60. Combine like terms, we get 16x squared minus 25 is equal to 0. And we notice that that is a difference of 2 squares. If you want to see an example of how to solve that, if you go back to type 1 on solving, you'll see a nice example that shows how to do that. But pretty much here we're factoring it to 2 factors. Each factor will have 2 terms. And you take the square root of 16x squared, which is 4x. That gives you the first term of each factor. Take the square root of 25, which is 5. That gives you the second term of each factor. And you got a plus sign between 2 terms in the first one and a minus sign in the other. And so then you separate your factors, set them equal to 0, and solve. So we get 4x is equal to negative 5, so x is negative 5 over 4. And 4x is equal to positive 5, so x is equal to positive 5 over 4. Alright, number 9. Again, I'm going to do a little bit of scratch work to try to figure out what I'm dealing with here, or to classify my quadrilateral. We're told that AB is parallel to DC, and AC is congruent to DB, so the diagonals are congruent. We're also told that measure of angle 7 is congruent to measure of angle 8, so I'm going to mark those congruent. And we're told that the measure of angle 3 and 4 are congruent to each other. Okay. Because the top and the bottom are parallel, we have alternate interior angles. I'll highlight them here, and so we know those are congruent. So my one arc and my two arcs are actually congruent to each other. So I'm going to make them all double arced. So all four of those angles are congruent to each other. Now, because all four of those are congruent to each other, the green ones that I'm highlighting are alternate interior angles, and we know they're congruent to each other, so now I can say that the left side is parallel to the right side. And so we have a parallelogram. But then go back and look at the AC congruent to DB, where the diagonals are congruent, and let me show you. Something that I wanted you to memorize is that if you have this property that diagonals are congruent plus a parallelogram, then you know you have a rectangle. So we know we have a rectangle. The question is, can we go further down this line? We got a parallelogram, right? We got from parallelogram to rectangle. Can we even go to a square? And so let's just take a moment and think about what we have here. Notice that this triangle that I'm going to highlight or outline, this triangle right here, is isosceles because the base angles are congruent. And so I can say that the top and the left sides are congruent. Also, we know the top and the bottom are congruent, and using a similar argument we can get the right side and the bottom congruent, because that's another isosceles triangle. So we can get all four sides congruent, making it a rhombus. Well, if you have a rectangle and a rhombus, then you're working with a square. So this took a lot of thinking, careful thinking to get here, but we're working with a square. So now that we know we have a square, there's a couple things that we're going to use. So in a square, first of all, we know that a square is a rectangle, and rectangles have 90-degree angles, right? And so I'll just write that down. All four angles are 90 degrees. So we're going to use that property. And then also a diagonal cuts an angle in half if it's a rhombus. And a square is a rhombus. So diagonals bisect opposite angles. Now if it's just a rectangle, we couldn't say that because that's not a property of a rectangle. but it is a property of a rhombus, and a square is a rhombus. So that 90 is getting cut in half to a 45. And so that tells me that the measure of angle 1 is 45 degrees. So we can now substitute in 4x squared minus 55 for measure of angle 1, set that equal to 45 degrees, and go ahead and solve this. Set the equation equal to 0 by subtracting 45 from both sides, and we get 100, negative 100. And notice it's a difference of two perfect squares. So I think we have an example of that in type 1, and it factors to two-term factors. Take the square root of 4x squared to get 2x as your first term in each factor. Take the square root of 100 to get 10, which is your second term in each factor. One's a plus 2x plus 10, one's 2x minus 10, and you can separate these, set them individually equal to 0. Now, some of you may be noticing I could have actually factored the 4 out, the GCF out, before splitting up to the difference of two squares, but when you're solving, we're going to end up with the same answer, and there's a little less work to do it this way. So 2x is equal to negative 10, so x is negative 10 halves, which is negative 5. So that's one answer. And here we get x is equal to 5. So positive 5 and negative 5. Alright, the last one I'm going to do with you here is we have another quadrilateral. Let's see, AB is congruent to CD. AD is congruent to BC, so opposite sides are congruent, so that proves a parallelogram. Okay, so we know we're there. Also, we have AD is perpendicular to AB. So that's right here. We got a 90-degree angle. And because it's a parallelogram, we can say opposite angles are congruent, so that would make this 90. And then adjacent angles add up to 180, or they're supplementary, right? That's another property of a parallelogram. So if I have 90 here, I need 90 here in this corner because they have to add up to 180, and I need 90 here because these two need to add up to 180. So you end up with all four angles being 90, and now we've moved to a rectangle. There's nothing that says all four sides have to be the same, so we're stopping at rectangle. That's as good as we can get. We're given information on AD, this side here, DC, that side, and AC, that side. Now we can't say that AD and DC are congruent, but what we can say about this is that we have a right triangle, right? What I've highlighted, that forms a right triangle, and we're involving all three sides, and so we're going to use Pythagorean theorem to help us out here in setting up our equation. So we're going to write that here. Remember, Pythagorean theorem says that if this is A, this is B, this is C, that A squared plus B squared equals C squared. And so for us, AD, that length squared, plus DC squared is going to equal AC squared. Alright, well, we're told that AD is x minus 6. DC is x plus 1. And AC is x plus 2. And here we're going to be following the type. Let me show you it. Under solving, if you go to type 6, you'll notice that it starts out that way. We have the form of a squared plus b squared equals c squared, and you notice everything's being multiplied out. It gets really long, and then we simplify it and make it equal to 0, and then go ahead and factor. That's what's going to happen on this problem. So x minus 6 squared means x minus 6 times another x minus 6 plus x plus 1 times another x plus 1 is equal to an x plus 2 times another x plus 2. And you just got to take your time and carefully multiply each one out. So if I go x minus 6 times x minus 6, I'll draw the boxes here. So x times x is x squared. You get negative 6x, positive 36. And so I'm going to write it below. We got x squared. We got two negative 6x's, so that's negative 12x, and a positive 36. So that's that part. Next, I'll do a little work over here. Got a little corner. We're going to do x plus 1 times x plus 1. So x squared plus x, and 1. So this is going to be x squared plus 2x plus 1. And I'll do a little work up here with x plus 2 times x plus 2. You get x squared, 2x, and 4. So that's going to be x squared plus 4x plus 4. Alright. I'm going to subtract x squared from both sides. I'll subtract 4x from both sides. And I'll subtract 4 from both sides of the equation so that the right side is equal to 0. And then on the left side, we have an x squared right here. We have a negative 12x and a negative 4x, which is negative 16x, and then we have the 2x here as well. So if we get all of them together, so we got negative 16 plus 2, which is negative 14x. And then we have a 36 minus 4, which is 32, those two right there, plus the 1 over here. So 36 minus 4 is 32, plus 1 is 33. And now we want to try to factor this. We've got three terms. We're going to use the trinomial factoring. And we're looking for two terms that multiply to 33x squared and add to negative 14x. And if you try negative 11x and negative 3x, it will work out for us. So we're going to split this up. X squared minus 11x minus 3x plus 33 is equal to 0. Factor by grouping. Both terms have an x minus 11, and you're left with an x minus 3. And so we end up with x equals 11 as one answer, from the first factor, because I take that x minus 11 and set that equal to 0, and I get x equals 11. And then x equals 3 comes from the second factor, because I take x minus 3, set that equal to 0, and solve. And so those are my two answers there.